Alright, so I got another video here on the Chimera7 PRO, and one of the, I guess, big questions from the other video I made on the Chimera7 PRO is why the bigger motors and bigger props, and if it's less efficient than the smaller motor and 7-inch props, why even get this? And as I explained in that video, it's basically to carry more battery, and well, iFlight saw the video and they're like, well, do you want to try out these 4,000 milliamp hour 21700 lithium ion packs? So these are a 6S1P pack made with 21700 lithium ion cells. Now, they have made these lithium ion packs before in the 18650 cells. They're 3000 milliamp hours. I think these are made with the VTC6 cells from Sony. Pretty good pack, but you can see it much smaller. Obviously, they're moving up to these 21700 cells. I'm not exactly sure who makes these cells, but because they're so much bigger, you get more energy capacity in those larger cells. Plus, they get some other advantages. Because the cells are bigger, they can take more of an amp draw. So this is going to be drawing more amps because it's kind of heavier, and this battery can handle that, but it's going to deliver more overall energy in the pack here. And there's some caveats you're gonna have to know about when you're dealing with lithium ion cells versus lipo packs. They behave differently, they charge differently. I'll get into all that here. This video is a bit convoluted and somewhat complicated to explain everything, but the idea here is to get more flight time out of this. Yeah, it's overall less efficient, but you're going to be able to carry a lot more battery because it can handle the extra weight, and the energy density in these 21700 cells are higher than the 18650s, so you can carry around more battery, more energy, and ultimately get more flight time, which is what I'm going to talk about in this video. Alright, let's get some of the boring specs out of the way first. So this cell, it's 445.7, 446 grams. In the spec page, it's 443 grams is what they're saying it weighs. Now the other one that I have weighs 445.9, so 446 grams for the two packs that I've got. And then comparing it to the 18656S pack, it's only 302 grams. So yeah, it's more than 100, almost 100, about 150 grams heavier to move up to the 18650 pack. And then I'll put up on the screen here what the dimensions are. Obviously has an XT60 connector here, 6S pack. Now when I got these fresh out of the box, they were at storage voltage at about 3.45 volts per cell. You can discharge these to below 3 volts per cell. Not recommended. They're saying you should not get these below 2.5 volts per cell. I think that'll damage the cells. These don't have a lot of energy left after you go below 3 volts, so I never tested going below that, because on some of the testing I've done previously on these 18650 cells, when you go down to where basically the battery has no energy left, the amount of voltage just kind of falls off a cliff. So you go from like 3 volts and it'll hang around there for a little while, and then it'll go for 2.9, and then it'll start to quickly drop off after you see, all of a sudden you see 2.9, 2.8, 2.7, and then before you know it, your quad's falling out of the sky. And I didn't want to do that with this guy, because with these two packs, which I put on here and I used a parallel Y cable so they can run both of them. But so basically with both of these plus the Hero 10, this thing weighs 1,800 grams, 1.8 kilograms. So if you do happen to get this set up, I definitely don't recommend going below 3 volts. When you get to about 3 volts, you're pretty much totally killed the battery, and it doesn't really fly that great. Like, it doesn't have a lot of punch out power or any kind of, if you need to punch out of something or recover or whatever, you're pretty much hosed. And if you're too far away, you're going to crash. So when you get closer to 3 volts, just start heading back right away. Actually, head back much sooner than that, because you can get a crap load of flight time out of these, and it's going to vary, of course. and I did a few tests. I'm not going to show you every flight. I'm probably showing you some sped up footage here. I'm just kind of going around in circles, basically. I wanted to get some data points on how much milliamp hours I'm pulling out of these packs based on the just kind of cruising around flight time. And for two of these in parallel, so if you actually use this in parallel, you have 8,000 milliamp hours total available to you. So I roughly, depending on how I'm flying and obviously flight conditions, if it's windy, etc. Obviously, if it's windy, you're going to draw more energy and use more energy. So those are all factors, but you can roughly expect on this setup here with a Hero 10 on here, with all that weight, roughly around 35 to 45 minutes of flight time in total. Now I'll give you a range there because it might be as low as that or it could be as high as that. This is kind of what I got in terms of my testing. And yeah, it's kind of boring because I'm just going around in circles. I'm trying to maintain like a cruising speed and not overtax the battery so much. Now these batteries are pretty good in terms of being able to draw more energy and like more amps because it is a bigger cell, but I don't recommend really pushing it because when you draw more current out of these cells, it actually draws more milliamp hours out of the packs than you realize, and you'll actually reduce your flight time by quite a bit. So if you want to get maximum flight time, you probably want to try and maintain a nice, steady, smooth cruising speed, not too much throttle, not too crazy on throttle, and you'll get the maximum amount of flight time out of these packs. So basically, long story short, that's why you want to go to the bigger prop and the bigger motor so you can carry the bigger batteries and get more flight time, because you can't get 45 minutes of flight time on the Chimera7 with the smaller prop and smaller batteries, or smaller prop and smaller motors. As far as I know, I put like a 4,400 milliamp hour LiPo on them. I didn't get anywhere close to that. That's the biggest battery I've got that actually fits on here. You can probably put more battery on that other quad. If I'm not exactly sure if that would be able to carry that much more battery, or what that would. I'm sure someone's tried it and they're going to swear to God they've gotten 5 hours of flight time on whatever battery they use, because you can carry batteries underneath as well as on top. How well that'll fly, I don't know. I wouldn't want to put a battery underneath anyway, because you'll be landing on that and smashing your LiPo when you crash when you land your quad. And 2 kilograms of weight on a battery is not usually a good idea. So a few other things to note: I only charged these cells to 4.1 volts per cell. Now there's going to be some debate out there whether or not lithium ion cells can go to 4.2 or not. I've done it before. I've charged these up to 4.2 before, but I don't generally recommend it. If you charge them up to 4.2 regularly, you can get a few more milliamp hours out of this pack. I would estimate maybe another, maybe 200 or 300 more milliamp hours, possibly. Maybe not even that much more. But you're reducing the longevity of the pack, in my opinion. I would recommend just running it to 4.1 volts, and a lot of chargers, when you switch to lithium ion, they'll only charge to 4.1 volts. I don't know which is correct. I'm sure there's going to be a lot of debate out there. Let me know down in the comments below which you think is correct and why, because I know for a fact that a lot of people think that 4.2 is correct, and then a lot of other people think that 4.1 is correct, and I don't see there's a consensus out there. But for me, I know that if you charge them up to 4.2 all the time, you do reduce the overall longevity of the pack, while you do gain a little bit of extra flight time for that one flight. So that's why I charge these to 4.1, and then I run them down to 3.0 volts to get that approximately 4,000 milliamp hours. So when I did that, and I put this pack back on the charger and charge it back up from 3.0 volts back up to 4.1 volts, it put in about 4,000 milliamp hours on this pack. Alternatively, you could go 4.2 volts down to 3.0 volts or 3.1 volts. It really kind of depends on what you want to do. It's all up to you, and obviously your mileage will vary. Your results are going to be a little bit different from mine depending on how you use the pack. Something else to note about these lithium ion cells is when you charge them, you want to charge them at a slower rate. If you charge them at 1C, which is in this case 4 amps for 4,000 milliamp hour pack, these cells do get warm. Now they don't get hot. I don't think you're in any danger of a thermal runaway or a fire, but at 1C it does feel warm. So I'm not exactly sure how this will handle that higher charge rate in the long term. Generally speaking, that heat is not good for these kind of cells. So I would recommend charging it at half a C or less to keep the pack cool or the cells cool. But the downside is it takes a lot longer to charge up these packs at half a C or a quarter of a C charge rate. So something to keep in mind. That's sort of the downside of these using lithium ion, is you have some limitations on how fast you can charge these up. Now regarding making a parallel Y cable, if you're going to get 2 packs here, you need a parallel Y cable. You want to run these in parallel and not series, and basically you need 2 of these. I don't know what these are called, male or female or whatever. These are basically 2 ends for the 2 batteries that match up. So you need 2 of these, and then you're going to connect the red to the red, and actually this one has 2 black wires. Basically you want to connect the reds up together and the blacks up together, and then you want the other end here that's going to go to the quad, and then connect the reds up together and the blacks up together, and that will create a parallel cable. And then basically you just plug in the batteries into these, plug this into the quad, and you basically have 2 of these packs in parallel, and you have to make sure that they're at the same voltage. So if you have one at 3 volts and this one at, another one at 4.1 volts, that's going to be pretty bad, because when you connect them together, all the energy is going to go zapping in from the higher voltage into the lower voltage at super fast speed, and you might get a fire. So yeah, don't do that. Make sure you check the voltage on these before you connect them up in parallel. They should be pretty much at the exact same voltage to be safe, and then you can safely use these in parallel. Anyway, that's pretty much it. These are pretty good cells. If you're looking to get the Chimera7 PRO and you're looking for maximum flight time, you want to get something like this. I think ultimately you probably want to get a pack that's already made as a parallel pack, basically built as a 6S2P pack, but this is okay as a workaround. It'll work because you're not really, if you're flying slow, you're not like going crazy on the throttle. You're using a parallel adapter does not really affect your efficiency a whole lot. Although if you're looking for the ultimate maximum efficiency, then you want to definitely get a pack that's a 6S2P pack, and not this situation here where you have to use a parallel cable. So it just, again, I don't have a 6S2P pack, so I can't tell you what the differences are. If you happen to know, if you've done this testing, let me know in the comments below if there is a major difference going with a 2 6S1P packs with a parallel adapter versus an actual 6S2P pack built that way, from the start. I don't think there's going to be that much difference, but if there is, let me know in the comments. Anyway, that's going to do it for this one. Let me know if you got any questions, and I'll talk to you guys in the next video.